Perfect. Yes, I'm Jean-Michel Munoz from Total R&D, and I'm working for the oil and gas branch of Total. And I'm in charge of our R&D project called the Next Generation Facilities. So I will just describe a little bit the project before starting the presentation that will be focused on our progress on robotics and our future plans on robotics. Because the Next Generation Facilities project is in fact the very reason why we're working on robotics. So to be short, because it could be a whole presentation by itself, the objective of Next Generation Facilities is to have, so I'm talking for a new installation that are usually remote site, is to have all our remote site in the future unmanned for very long duration. So when we're talking about a very long duration, for us, it means like a year. So nobody on site for a year, and then a short maintenance visit, basically 2 weeks maintenance campaign, and then again, 1 year operation unmanned. So to achieve this, we're working on the many topics: the architecture of the field, technology of the components that will be installed on the facilities, and also how to do some remote operations. So the benefits that we found in all this is that there are many. First, there are HSE benefits, safety, because we drastically reduce exposure of our operator by removing them from a potential hazardous situation, but also CapEx, OpEx, and even environmental footprint we're reducing because we have less logistics, etc. So for us, it's really a good way to go, and we consider it as, I would say, a new frontier for cost reduction. So now focusing on robotics. So if you imagine that there is nobody on your site for 1 year, you have to answer to the very question, what if something happens? So here you have basically two options. One is to try to automate the whole installation, even automate, I would say, equipment that was not automatized before when the platform is manned, I would say. But this one adds complexity to the installation, so we don't go this path. And the other one that we follow is to have a multi-purpose mobile robots on a very simple installation. So now I'm going on the presentation on the robotics. The picture that you have here on the screen is our robotic lab. I will come later to that in the presentation. So basically, we're following several paths today on this project regarding remote operation. So one is to try to develop the technology. And here you have an overview of what we're doing right now. So basically, we think that if we have 3 different types of robots, and if we have a combination of these robots on site, basically V1, V2 or V3, if you see my mouse, maybe this, V1, V2, and V3, we will be able to operate any type of installation. But as a basis, all of our robots should be autonomous. So here, autonomous is, I would say, versus teleoperation. In fact, we don't think that we will teleoperate our robots much. It will be maybe less 10% of the time, maybe in very specific occasion or in downgraded mode. Autonomous for us means, like, for example, for navigation, you would just specify 2 points to the robot. We say you are in point A, you go to point B, and then the robot will find its route, and going to point B without any intervention of the operator. It could be also you ask the robot to open a specific valve, and from where it is, it will go there to the valve and it open or close it by itself. So that's what we mean by autonomous. ATEX, so it's very important for us. So ATEX is more European term. It would be ICEX for the states means that our robot needs to operate in potential hazardous area. If we have a leak of gas, there's no point to shut down the robot because it cannot go in this area. So we need the robot to go and investigate in possible leaks. So they need to be attack zone 1. If it's not attack zone 1, it's kind of useless. Needs to be water resistant because it's outside all the time. So mobile. So mobile, we mean it has to go everywhere on the installation and even climb stairs or go downstairs. For example, what we require for our robot is to be able to climb the stairs that are specified in our specification. It's like an inclination of 42 degrees. So we ask for the robot to be 45 degrees. Multipurpose here means that, well, the robot has a big, I would say, can have a big loads of sensors, different sensors, and it can use also some specific tools. So it can do many tasks, remotely operated, of course, because there's nobody on site and we have to be able to operate them from hundreds of kilometers away. And I put 27 service, means that they have to be really reliable. So regarding what we've done this far, well, the journey on robotic with Total started with the Argos Challenge in 2014. Here we had a 3-year open innovation competition where we had some international team competing, and it was for us some sort of a feasibility study, I would say, seeing that if we could really have a robot that could be characterized by just described up here. So the winner of the competition, we're still working with them, came up here with the world first. It was the first ATEX autonomous ground robot at the time. So since we proved that it was possible, we continued our journey with what we call the O-Grip project. I will define it better later on. But the idea is that this robot is an anomaly detection robot. It doesn't touch anything on the installation. It's like just having your eyes, nose, and ears. It goes around the installation, does the operator mount. But with that, we cannot operate the installation alone. We need something else, and which is why we're starting a GIP. So the Argos GIP, so Argos is the acronym for Autonomous Robot Gas and Oil Site, and GIP, for those who are not familiar, is Joint Industry Project. So we're partnering here with Equinor from Norway and the Oil and Gas Technical Center of Aberdeen in UK. So we started this GIP to create what we call a working class robot, means robots that are able to interface, manipulate, do things on the installation. So right now we're on the phase 1, working on the simple manipulation robots with a robot that will be able to do more specifically, I would say, operation tasks. And later on, we'll work on the phase 2 for a robot that will be able to handle more complex manipulation, something that would be more, make more reference to maintenance tasks. Okay, so next, up. So next slide here. So just a few words on the O-Grip robot. So the O-Grip is for offshore ground robot industrial pilot. And now it's known under the commercial name of the Torop Inspector. So basically this robot has a big payload of sensors, multiple cameras, microphones, can hear sounds, gas detector, it has gas finding camera, thermal
dynamic operator control platform.
So the robot basically can be used for operators round. So like most of operators do, you know, very regularly, they will run the installation and try to see, identify what the panelist in the control room cannot see. So we're about at the end of this development today, and we will deploy the robot very soon on the Shetland gas plant in north of Scotland. So it's an island 500 kilometers away from Aberdeen. We chose this site because they volunteer, it was very nice from them, but it's also very close to the ocean, which is good for us because it's like almost offshore conditions, and which is most of our case in the future. So I'll just give you a little overview of the timeline of the project. So the project started in March 2018. And from there, we went on the site several times to do some basic survey. And from here, using on the, I would say, previous robots, the components that we wanted to put on the future robots, like a LiDAR, gearbox, and other types of sensors, trying to see if they worked. Then we built a prototype, and we were there several times on site with this prototype, then later on trying the telecommunication and trying to do these autonomous missions, each time trying to raise the bar, in difficulties, to the point where we were also able to climb stairs autonomously. So we had a very big deadline here in February 2020, because our CEO wanted to do the investor days in Aberdeen. And then we were asked to do some demos for the robots. So we had the privilege to show to the investors live demos. So that was no room for failure here. And it was very successful. And we'll show you a little video of that so that you have some sort of insight of how it looks like. Difficulties to... don't know how to transfer the video. I try to close. Sorry for that. Okay. So here we are in the control of Shetland gas plant, and that's the control space for the robot. So here everything is autonomous. The lady that you saw just click on the button to start a mission. What the mission here for the robot was to go on the 3, I would say, checkpoints that are typically analog gauges or valves, so that we can check the position of each of these items. So the robot is in fact collecting data here. It could be an image, a video, or it could be recording a sound. What happens once this data is collecting, in fact, is that this data goes into a cloud where there we have algorithms, and it would be analyzed there. So the intelligence is not for the analysis of this data is not in the robot. It could be there, but depending on the situation of the site, if we have good telecommunication or not, we could as well put it on somewhere else in the cloud, so that would save us some energy on the robot. So you know, the robot is, the navigation is really autonomous there. If there was an obstacle, the robot would go around it, without any intervention of the operator. So now I just stop here because I lost a little time before. So up. Going back to the presentation, I hope you see it. So we, so what happens next? So next thing now would be to give the robot to operation, really to hand over the robot to operation.
You hear me?
Because up until now, the robot was operated by the research team.
Yes, a little bit.
And robot manufacturer.
Fine.
So we plan to do it by October 2020. Of course, we've been impacted by the COVID as well with the restriction.
Bonito ese vestido.
Because it's, sorry, no. So we've been impacted by quarantines and things like that. So what we did in the meantime, waiting for
Sabes que tenía muchos slides, tenía más
October
slides. Te
deadline,
puedo cortar.
And your mic is on. Could you switch it off?
So waiting for October, we had the opportunity to go ashore, and this is what we did in
pues ahí
Netherlands.
poniendo, es que estos son estresantes. ¿Sabes cuántos?
Oh.
Ya, 700.
Yeah,
Ya acabé. 700 personas.
And,
pues sí, esa es la idea. Nos vamos para Francia. No,
oh,
pues.
Can somebody shut the mic? Because it's, oh. So, yeah, we had the opportunity to go to Netherlands in August. So it's very new, and we're very proud that we think that it's a world first to have autonomous operation with robots on offshore on the oil and gas platform. So that's what we did there. In fact, the robot was there for a small week, and during this week, it was in fact we were very happy with the results, meaning that in less than a day, we were able already to perform some autonomous mission. Means that in the morning, because we didn't know the site, we were able to scan one deck. So the size of the deck was 30 meters by 30 meters. So it took 2 hours to do that. We will then identify some checkpoints, and with the autonomous navigation software, the robot was able to go from checkpoint to checkpoint. So we did this for several days, showing the capabilities of the robot to the operation. And we also put an extra payload of sensors and try to do a corrosion survey with the robots, and to see if it could be as good as something done by human. So, so what we are currently doing now, because it's still in the research, so we're in the phase 1 of the simple manipulation robot. So for us, the objective here is to have a robot with a strong arm. So one arm that would be able to push, pull, or give some torques to do some basic operator's tasks. Basically for us, I think this robot could be very useful on very simple installation like wellhead platforms or well pad. That's the equivalent onshore. So it's quite a strong arm because we want the robot to give 150 Newton meters. Of course, it will be still autonomous, have lots of sensors, camera, and things like that. I'm going to shift to another aspect of our research. So here you saw what we were doing on the technology, but now we have to think about how to learn how to use robots, because there is no real operating manual on how to do things. We're really pioneering here. So we need to try to test and do experiments. So which is why we have in LAC, so not too far from Po, what we call our robotic lab here. And so we've built something with, I would say, decommissioned equipment, added platform, so that it looks like what we could find offshore or anywhere in the oil and gas industry. So that gives us to test many things. First, to see how the robot works, try to get familiar with the operating envelope of the robot, see the limitation of the robot, and see its reliability, really trying to do a test after test, and try to identify all possible use cases, because it's only when you try that, in fact, you find these cases. And that also gives us the opportunity to do some modification installation, or at least try experiment Like for example, we're building ramps instead of stairs sometimes and see how it goes. Or we're putting some pallets on valve, see how it goes. And it's very nice because we go, from studies to reality there. And so this space is very good because for us, it's really trials and error sites. We try to do some training, and it could be a showroom, to give confidence to management or field operation team. So up till now, you've seen, I would say, pictures with one robot, which is nice. So we're trying to learn with this. But in the future, the value will come with operation with multiple robots. Because there is so much work on one platform that one robot will not achieve all that by itself. So we need multiple robots, and in fact, we'll have a fleet of autonomous robots on the platform. So how to control this? And that's another aspect of the research of what we are doing now. So here it's a very simplified sketch of what we would find in the future. So I will just, oh, sorry. No, sorry. Voilà. So just try to describe this. So the standard site, on the standard site today, you will have the control room with a base support of the base or smart room for those who are familiar with. You have all the equipment of the site equipment, pump, valve, compressor, etc., that are controlled through the ICSS and the instrument control safety system. This is linked in the control room. On the standard side, what you have here is operators that would be also controlled from from the control room. So in the future, this is not going to be the case because if we say that we are remote and say that here we are in the ocean very far, so there is nobody here except a fleet of autonomous robots or autonomous system, because that applies also to drone or some unmanned vessel that we have. So we've added in the architecture of the field a new element that we call the operation room. And to make an analogy of what we could find somewhere else, it could be like a control tower in an airport. And here the panelist would be like the air traffic controller. They will, I would say, monitor the activity that is done by the robots on the field. So that would be done with what we call a fleet management system that will be interconnected with some of the software, like a digital tool for navigation, and what we call a task scheduler. The task scheduler is more the computerized maintenance management system. So just to give you some sort of insight of how this is going to work, you know, the CMS, the maintenance management system gives every day to the maintenance team the work orders to go on each equipment according to the vendor's recommendation. So that will be translated in some language that the robot can understand, and the fleet management system will distribute, I would say, all the activities to the robot autonomously according to where the robots are, their battery charge, and the capabilities of each robot. So all this done autonomously. Of course, the operators here will still be able to operate a robot if needed. And we also imagine that we have some slave master link between some robots for more complex tasks where we need 2 arms, for example. Yeah.
Michel, you have got a few minutes.
Yeah, and I'm almost finished. So that was, here's my conclusion slide. So well, I showed you the 2 aspects, the technology and how to learn how to integrate these robots on our site. Here on this map, it's where we operate now. So we didn't go on every site for time savings. So we, as Total, we believe that ground robotics can really be an enabler for what we call normally unmanned facilities of the future. It's for us a next cost reduction frontier. We are present on every side and every aspect, technology and also integration of the robots. And we have many challenges ahead. And I think that the more operator will work on this topic, the faster we will go. So this is it. So please, if you have questions.
Thank you very much. Michel, we have got so many questions on the chat. I will select some ones. How will robot deployment would change chemical plant design? What about plants specifically designed to be operated by robot?
Okay, so this touches another aspect of the project when I said at the beginning that we're working on architecture and technologies. For the plant of the future, one key element, one KPI, when we try to build an installation is the site working hours. And we try to really reduce this as much as possible. So to go on this plant and chemical plant of the future, I mean, from design, they have to be as lean as possible in terms of site working hours. Yeah, so there was two aspects on the question. Was if you can come back to it. I think I forgot the other one.
How? What about plants specifically designed to be operated by robot?
Okay. Yeah. So as I said, you have to do it to limit as much as possible the site working hours. But you know, this is not that very new for the industry, at least for the oil and gas. Because for the past 20 years, we've had some operation subsea with installation now, separators, valves, wells that are 1,000 meters, minus 1,000 meters under the seabed, or 2,000 meters, and they're operated by robots too. What's important in the future is to have difficult. Yeah, robot-friendly operations equipment.
Yeah, okay. Well, there's pita bread as well. There's a lot of pita.
It's fine. With there's my thing.
So there's some noise on the background, so it's difficult to answer more.
Your mic is on.
David, sorry. David Boger, your microphone is on. Will you close it?
Sorry.
Thank you.
Yeah.
Sorry.
So to have a friendly, a robot-friendly installation for us is one aspect that we are looking at here. For example, how to change the interface for valves, how to facilitate the navigation of the robot. It's easier to have robots on, I would say, greenfield, what we call greenfield, new plants that have been studied for it. But just the same, it can bring benefits to brownfield as well.
Another question, do you use co-robots?
So here you mean probably the connection with operators and robots working together. I would say we don't do this. We don't do this. The robot could be close to the operator, but you know that these robots are also quite powerful. And anyway, the direction is to go unmanned. So we won't have this interconnection between human and robots in the future, at least maybe momentarily, because we have to go to a manned site today. It's only what we have. But in the future, no.
Can you provide an idea regarding battery duration as well as charging or exchanging batteries?
Okay, so this is good also, and this is one of our research topic here. So today with this surveillance robot, the first one, we have a pretty basic battery. We have a 2 hours operation time, and the problem is that the recharge will be 12 hours. So this is not good, which is why we are working today with SAFT, which is a leader in the world of battery. And so here we're working on lithium-ion batteries that would give a lot more autonomy to the robot. And basically what we target here is a 4-hour operation with a 4-hour recharge. And the good thing is that this battery will also be ATEX. So this is a world first here, because we're talking about big capacity batteries, lithium ions that would be ATEX zone 1.